Reciprocal functions. First definition of a reciprocal mathematical expression related to another such that their product is 1. I know most of you know what reciprocals are, but here's a few examples just in case you didn't. 2/3, 3/2, -1/4 and -4, x plus 2 and 1 over x plus 2, x and 1 over x. And really this is what we're going to be getting into during the course of this video. We know how to graph linear equations, you know how to graph rational functions. We're going to see how the two of them are related. So first we need to learn how to divide by big and small numbers, and what I mean by that is divide by 0 and infinity. How do you divide by 0? And how do you divide by infinity? Two things I don't think we've talked about before. So first, let's start with some simple questions. 10 divided by 1 is 10. 10 divided by 10 is 1. 10 divided by 100 is 1/10. And you go ahead and finish that table and see what you come up with. When I do that, I see that as I divide by larger and larger numbers, so as this number in the denominator 1, 10, 100, 1,000, 1,000,000, as that number gets bigger, my answers are getting, hopefully you're realizing, smaller. And the smaller they get, the closer they get. If I had to round this answer, what would I round it to? Hopefully you're saying 0 to yourself. Therefore, I can generalize this and say that 10 divided by infinity, or really any number divided by infinity, is going to give me 0. Let's try the second half here. You go ahead and fill in this table and we'll see what it looks like. So as I fill that table in there, I see that 5 divided by 10 is 0.5, 5 divided by 1 is 5, 500, 50,000, 50 million. So the smaller the number gets that I'm dividing by, notice how my denominator is getting smaller and smaller and smaller, the bigger my answer gets. Therefore, I can generalize this and say that dividing by 0 actually is allowed, and that gives me infinity. Okay, so this is definitely an idea here that's different for us. Now remember, you can't actually divide by 0. We're just saying that as that number gets closer to 0, our answer is going to go to infinity. You'll see what I mean when we look at the graph. All right, now relating this to reciprocals is the important part. Any number divided by 0 is going to be a big number or infinity. When we say big, we mean infinity. When we say small, we mean 0. Any number divided by infinity is going to give you 0. Again, any number divided by big equals small. And when we say infinity, we mean plus or minus, okay? We mean plus or minus. So negative infinity is not a small number. 0 is the small number. Relating this to reciprocals, remember reciprocal, if you're flipping 0, it's now dividing by 0, 1 divided by 0. So the reciprocal of 0 is 1 over 0. So the reciprocal of 0 is infinity, because dividing a number by 0 gives us infinity. The reciprocal of infinity, so remember infinity, if I take the reciprocal of it, I'll have 1 divided by infinity. We just said on the last slide, dividing by infinity gives us 0. That's the core concept. This is what we need to know to graph reciprocal functions. So let's take a look at what I'm actually talking about here. Here's a function. All right, it's a linear function. We graphed it. There's a special place on this graph. That special place is where x equals 0. Because remember, no matter what this equation gives us, okay, it looks to me like the equation here is what? Up 2 over 4. So that's a half. X minus 3 is my equation here. If I take the reciprocal of that, it's going to be 1 over it, which means anywhere that denominator equals 0 is going to be undefined. That gives us our VA. So anywhere you have an x-intercept, the reciprocal function is going to be a vertical asymptote. Now, here's where the tricky part comes in. As I'm leaving that asymptote, my y values are getting what? This arrow means my y values are getting bigger. They're going to infinity. So the reciprocal of infinity is 0, which means my reciprocal graph has to get closer to 0. As I go towards the asymptote, my blue line here, as I go towards the asymptote, my y values are getting closer to 0. Okay? that means their reciprocal is going to get closer to infinity. As I leave this asymptote, my graph is going down to negative infinity. All right? The reciprocal of negative infinity is 0. So this line gets closer to 0. It's not going to cross it. As I come towards my asymptote, my blue line is getting closer to 0. What I mean by that is here the y value is -4. Here it's -2. It doesn't get to here, but if it would, it'd be 0. So the reciprocal of 0 is infinity. That's my reciprocal graph. So you see how the reciprocal of a linear is a hyperbola. Let's try another one. This one has 2 x-intercepts. Anywhere there's an x-intercept, the reciprocal graph is going to have a vertical asymptote. Now, that's the easy part. Everybody should get that. The hard part are these questions here and interpreting this. As I leave the asymptote, my y values are clearly getting larger. They're going to infinity. Therefore, my reciprocal graph, my y values are going to get closer to 0. It's not going to cross 0. As I go towards my asymptote, my y values are now getting smaller. 4, 3, 2, 1, smaller. The reciprocal of small is big. So my reciprocal graph is going to go to infinity. Same thing over here. I'm leaving the asymptote. My y values are getting bigger, 3, 4, 5, which means as I leave the asymptote, my reciprocal graph gets smaller, closer to 0. As I come towards the asymptote, 4, 3, 2, 1, 0, my reciprocal is going to go to infinity. Sometimes you'll actually have a true data point. Here, my y value is -2. The reciprocal of that is -1/2. That's a measurable point. I can plot that point. Now, think about this. As I leave that vertex, my y values are getting smaller. They're going towards 0, which means their reciprocal will get bigger, going to infinity. As I leave the vertex here, go to the asymptote, my y values are getting smaller again. They're getting closer to 0, 2, 1, 0. Therefore, their reciprocal will get bigger, negative infinity. So that's the graph of my reciprocal function. Here's the last one. No numbers here, not even necessary to have numbers. Go ahead and give this one a try and check back. So this should be what you end up with. Again, let's just go back through here. I have a VA at this x-intercept. I have a VA at this x-intercept over here. I have a VA at the third x-intercept. Notice how these leaves here that go on forever, I have a hyperbola-looking graph. Okay, as I leave the asymptote, y value is getting bigger, therefore reciprocal gets closer to 0. As I approach the asymptote, y value gets smaller, therefore reciprocal goes to infinity. Okay, same thing here. As I leave the vertex, y values get smaller, reciprocal gets bigger. Smaller, reciprocal gets bigger. Same thing. Leave the vertex, reciprocal is getting bigger because my original graph is getting smaller. Last, as I leave the asymptote, graph's getting bigger. It's going to negative infinity, which is a big number. Therefore, reciprocal gets smaller. As I approach the asymptote, I'm going closer to 0. Therefore, reciprocal gets bigger, goes to infinity. Graphing reciprocal functions.